Hello. Let me just see if I'm online. And hey, I'm online. Okay, so tonight I'm going to be talking about the JDY-08, which hopefully you can see in shot over here. So the JDY-08, it's a Bluetooth module on a chip. It's actually a system on a chip with Bluetooth on board. I believe there's an 8051 and a bunch of other interesting stuff, different firmware you can flash on it. And I received this for free from a place called icstation.com. And I've been trying to get it working. So I've done a few previous videos doing stuff with it. And I suppose we're going to get straight in. Now, expectations, where I got to last time was attempting to flash firmware on it, attempting to talk on it. And because I was doing stuff on the other projects, this hasn't had any real development since then. So expectations, there's going to be debugging, there's probably going to be looking through data sheets, there's going to be trying stuff on serial. I'm expecting to be on maybe until about 10:30 tonight, so about 2 hours. Before I get into that, one other thing, kind of a bit of a news item if you like. This weekend I'm going to be at the Raspberry Pi 5th birthday in Cambridge. So I'm going to be there with my little helpers as well. So that'll be fun. And I'm looking forward to actually getting my hands on a Raspberry Pi 0W because everywhere I've gone online, they've all sold out almost immediately. Right, okay. So recapping with this, where we were last week is, and this is just a standalone one. Yes, I bought a second one, which isn't the one that was originally sent to me. So ignore the ESP over here. That's from another project. So here's the JDY-08 mounted on a PCB. And this is a PCB of my own design where I've broken out nearly everything. And I've broken out extra lines to where I thought serial was going to be. However, the serial may depend upon what firmware is running on there, so there may have been a foolish or rash decision on where those are, but I'm not directly plugging into those. This is then going to a voltage level shifter, which is in theory bidirectional and has 4 channels, so that should be helpful. That's then going to an Uno, which is loaded with this CC Loader software. So CC Loader appears to be a way to load new firmware on one of these devices, and we were trying to load CC Loader because I wasn't getting it to talk to me over serial. So the data sheets that I found for this, which is kind of something that people have been putting together, almost a collaborative project on Google Docs, has some details on flashing new firmware on it. It didn't really detail what the firmware on it is supposed to do. It only showed a few pins connected, so the rest I'm assuming are floating. Maybe some of them are pulled up and pulled down by the various devices we can see there. So we've got a whole set of resistors on there that might be doing something. Okay, so before I plug any of this in again, let's just go back to what we were wiring up. I'll just go find the and I'll make sure that I can see chat window at the same time, and there we are, and let's switch to so here is the data sheet, the collaborative data sheet if you like, and if you've not seen any of the other parts of this, so it's a Bluetooth module. It's actually a Bluetooth low energy module, Bluetooth 4 module. I've not yet got it to do anything Bluetoothy yet because I've not yet got it to talk to me via serial properly yet. So it's using the Ti CC2540 chip, which is I think what you've got right here in the middle. And so quick start, not part of the original data sheet, for experience in other BLA modules. Okay, so I suppose I've not done stuff in the BLE arena. I've just done stuff with IoT and system on a chip modules. So warning, some functionality may not work, password pin authentication, blah blah blah. And serial TX. Right, that's a bit worrying if that won't work. Okay, and they say they hardly recommend to upgrade firmware V540 of HMT or V263 of JDY-08. So I started off by going straight in for these refs over here, these which I think is this one, except we're on page 5. And I suppose I'm assuming that other than this quick start, there isn't anything here. I mean, there's this part here with the serial. These are the pins that I've wired into this header. Can I get full screen me and work? There we are. Okay, right. So these pins down here that I've set up for serial are wired into this PO2, PO3 here. We haven't gotten to a point where we can do AT commands, and we have tried 115200. I think we've also tried 9600. So we can retrace those steps, I suppose, but we need to rewire this first, because this is, I think, wired up for the flashing, which we didn't get to work. So, and then we attempted to get this with this CC loader code, which I have, let's see, over here. So this came from Red Bear Lab. Now, CC2540X, so it's the right chipset or right chip family. Somewhat different breakout, but okay, that's fine. I mean, if it's the same chip family, that shouldn't matter too much. So D6, D5, D4 reset. So that data clock and data, I suppose. So there's only 3 pins, and so we've got something going to reset from here, which is pin 4, going to that 3rd pin there, coming out of that 3rd pin here. We've also got here a 3-volt power thing, although if we're going off of the Arduino, instead of powering this at 5 volts, we could just power that directly at 3 volts instead and skip this. But I measured this last week, and we can get into that again. I mean, I measured that with my multimeter, which relatively trustworthy. I mean, okay, I suppose I've not had it calibrated fully, but it appears to be mostly working, so that's okay. So we've got then, so pin 5 going to this top one, which is going to P22. So let's just quickly go. 5 here is supposed to be going to DC, so some kind of clock, and pin 22 or P22 is a data clock, so 5 to 22 sounds correct, and then 6 to 21, so 6 going to 21, which is your, I suppose, the debug data. Okay, so we're using, obviously, it looks like we're using this debug lines to try and do the loader and the programming. Okay. Oh, that's odd. I wonder how we ended up with a WAP version. That's very odd. I've not seen a WAP version of a page for a long time. Okay, this is actually just a later place in that same topic, so let's just forget that for now. So hardware, Arduino, yep, USB TTL converter to connect the Arduino to PC. Well, actually, this is an Arduino that does straight USB. We got our board, some wire, soldering iron. Well, okay, we've soldered it onto this breakout. So we have the CC Loader Sketch, the CC Loader Windows program. CC Loader Sketch is running on this Arduino, and the CC Loader Windows program is over here. So let's just go and pop ourselves out a command window over there and say D. We'll switch to, oh, no, didn't want to do that, just that. Chat seems quiet tonight. Don't know if there's many people on yet. Okay, so let's start from here and looking at the Arduino as well. And we looked at this code, and there was a place in this code which suggested if such and such do such and such for the we go, where's the main? Let's go right down to the main. setup. If using the Leonardo as programmer, we should add the code below, otherwise commented. So we're not using the Leonardo, so we can leave that commented out. That's fine. Everything else, I'm going to leave it as is. Let's just check the pin numbers it's expecting to use. Oh, okay. So reset for 5 and 6, data clock, data. Okay. I'm not going to, I mean, I did quickly buzz through this last time, but I'm not going to really go into too much detail. I'm going to, for now, and unless we really get in deep, I suppose for now I'm going to trust this. We may have to dig deeper. And we may also have to have a look at the CC2540 datasheet. So what did we do? We had, so you've got the CC, if I do dir cc loader, so that is the Arduino code. We've got this ccloader.exe, which hopefully will give you some help. Yeah, okay. So we've got, what do we want? We want COM number, and let's plug it in. So we've actually got a COM number, so still the workday here. Oh, okay, of course, yes, different time zones. Okay, hello Paul, and that's fair enough, I understand that. Yes, international hours are sometimes tricky, I suppose. That's fair enough. And what have I plugged in? Oh, hold on. Hold on, I'm going to give myself some more wiggle room here because there we are. Right. So let's just make sure we have power across the thing. So we should have between here and here, and I've not cleared up the solder residue on there. Oh, okay, what's going on there? That's immediately, oh, there we go. No, that's it. I just had to kind of push through the residue from the flux. Okay, so we got that there, and I'm assuming those go across to here. So if I measure this, I should get the same. Yep, okay. So there is power on that module. That's a good start. And let's go and find our COM number. Oh, I didn't notice I'd gone offline. I'll have to watch out for that again tonight. It was pretty good last week until there was a certain point where it started getting difficult. Okay, I've just gotten this devices and printers, which is taking a little while to get there. So that's slightly frustrating. Windows can sometimes do this if there's some device it's being cagey about. I wonder what has set it off there. Because we need to know obviously what COM port number it is to feed it in here. Okay, that's not a healthy reaction. Any notifications of stuff not working down here? No. Okay, there we are. COM7. Hello. So that's interesting in itself. If that, yes, now I think we did go around and try and pair that. We didn't know really what to get it to do, but we did get it to pair in some way. So does that mean it's actually online? Category unknown. Properties. Hardware. Services. We don't know what kind of service it is because we've got no drivers. We don't know what it's supposed to do. That's fair enough. And I suppose the first thing I'd like to try and get going maybe would be some kind of serial port protocol. Okay, so 7. So we should be able to go what? 7, 0, and CC254. That thing. No? Oh, wrong os. Okay, so that was what we tried last time. The bin file name is invalid. Oh, sorry, it goes the other way up. And this is where we're expecting some activity on the Arduino, which we did not see. So if I take that on face value and say 3 seconds we got nothing, did we see any activity? Because I wasn't paying attention. So we see 1TX, no response. Okay. So have we got this running there? Well, we can be sure we have this running there if we upload it now. See, and of course this is all writing bytes either side, which I kind of see the efficiency of, but the tricky thing is therefore you don't get much debug from what's going on in here. And it would be nice perhaps to have more debug of what is going on here, and then perhaps open up bytes. But anyway, that's different. That's just right. Okay, so I've uploaded that. That should be therefore running again. Let's hit reset on that and try this again. No chip detected. Upload failed. File closed. COM port closed. Okay. So no chip detected. Do we have chip ID? Continue verify. KRX buffer. Read chip ID. Oh, we can't control click through in the Arduino IDE, can we? So I'll tell you what. Let's not navigate the code in the Arduino IDE. It assists with the actual looking up of stuff, but let's go look at that in here instead. So no chip detected, run loop again, read chip ID. Oh, I don't have a click through there either. Okay, I probably don't have I need some kind of C extensions. It's obviously got the code highlighting on. So make sure DD is output, DD being, that was that pin 6 or 5, pin 6, okay. Oh, I've lost it again. There we are. Okay, so delay 1, now delay, is that in millis or micros? I'm just going to refresh myself. Arduino delay. Let's just look. At milliseconds, so fair enough. Okay. So it's millisecond. Write debug get chip ID to the command to the chip. Now returns a chip ID returned by the DUP. So this is what some updater, some system on there. DUP into debug mode. Programmer IOs, what do we configure in the IOs? Right. Well, that may depend upon the maybe on the firmware that's already on board. So I don't even know if the firmware on board supports this stuff. Is this supposed to work on any of these devices, or does this need to have a device in a specific mode? It's just those things. And that OX68. Okay, right. Let's dive in to, hold on, I've got to find the right window. That window. So burn this firmware using this Arduino board. Wire the pins. Just make sure nothing's getting hot or bothered over here. Nope, nope, good. Because when things are in this state, there's always a concern, right? Is there any further documentation here? Oh, and that's the actual CC loader source code. So this is talking at the other end. Okay, right. So that's where it's reading the bytes back and turning it into debug messages. But that's not what I'm looking for. So this will be about the AT commands, but we're not probably talking AT mode at this point. We will be talking debugger mode now, and we're on different pins from the RS232, yeah, the serial. So I'm wondering if here DUP, what, debug something protocol, Ti CC2540. Is it 540 or 541? Let's just check. I'm sure there. 2541. Data sheet. Let's see if we can find out about this DUP. Hardware debug support. I'm looking. Found that somewhere here up on this data sheet. Presuming it's somewhere on either on these I/O controllers that go across to it. Debug interface, there it is. Right, I see. 8051 CPU core. So okay, are we actually sending something to this to, in theory, tell it to then go and, well, okay, it doesn't show where flash is on this, does it? So, oh yes it does, it's over here. Right, I see. Okay. So now here's where I want to say, okay, that's the debug clock. I'm going to assume for now, unless I want to dig deeper, that that stuff is fine and dandy and correct. Debug clock, debug data, okay. P21, P2 underscore 2. Okay, so it's not P21, it's P2 underscore 1. Okay, so what these are port interfaces, port 0, port 1 and port 2. Which makes sense, and okay, they've just kind of labeled them up and I've followed the same labeling, right? And that's going to be exactly the same here, P21, P22, so 21 DD 22 debug clock. Okay, awesome. I'm at a similar, very similar, it's an identical block diagram. Okay, now someone stop me if they know on the chat if this is some again standard 8051 thing. Debug interface, proprietary 2-wire serial interface used for in-circuit debugging. It's possible to erase program flash memory control, which oscillator enables stop and start execution, execute, set code breakpoints and single step. Sweet. So if we can actually get that to do stuff, could even single step. I mean, that on something like this would be pretty awesome. But let's see if we can get it to talk to us at all first. Okay. Well, that's all of my versions of debugging. Okay. What is this TI debug interface? Is this TI or is this 8051? Okay, app note there. Right, we're just into hardware diagrams. Are there further? That's projects, products. Is E2E community? Maybe. True system on chip, blah blah blah. Okay, no. Wait a minute. So is this a TI 2-wire debug interface? Let's try it. I mean, I'm not sure this is it, but it's worth a shot. Stellaris microcontrollers. Well, we're not on those. Serial wire debug. Maybe. I don't know. 10 pin. That's not it. Spy by wire interface. Is that anything like what we have here? MSP 430, no, I don't believe so. Okay, what about Ti 8051 two-wire interface? Oh, CC2540 debug interface. Hello. Application note. Oh, blimey. Right, okay. I'm just looking at this great big programmer. However, this great big programmer has got a grand total of 1, 2, 3, 4 wires connected, which may be power, ground, data, and clock. And maybe you press a reset button. Debug data, debug clock, device under programming. Right, okay, so when they were saying in, hold on, in here, right, debug byte, returned by the device under programming. Okay, like device under test, DUT, DUP. Okay, cool, so that's not special terminology there. Debug interface, programming object flash, bidirectional for the data DD. Okay. This is a bidirectional device here, so that should be okay. Sample on negative edge. Debug commands external host, 1 for output byte. Input byte read by the host. So the only possible, I mean, okay, so we'll keep going first. For more details, CC245X user's guide. Okay, does it? So that's your hardware setup. Right, reset P2 on P2. Okay, which is give or take what we're doing. I mean, that's pretty much it. Entering debug mode, debug init. Reset line low, toggle negative flanks on the debug mode. Okay, so is that what we do here? Before we read the chip here. Serial begin, setup and loop. So I suppose it's going to be standard Arduino while we still should go. Verify, serial read, debug init. Does that do a serial thingamy? So set them both low, right reset low, wait 10 milliseconds, clock high, clock low, clock high, clock low, reset high. So this is following sequence on the reset and clock line. So reset low. Okay. We go 2 negative on the DC line. Okay, what 1, 2, or is that? Oh no, 1, 2. Okay. High, low, 1, 2, and then we release that. So that should put us in debug mode. Okay, reading the chip ID. So, okay, this is fairly low level, but I suppose, you know, it's worth knowing how this is operating. So we've got some idea on what we're trying to debug here. So in which case, we can close this. So this appears to be doing the right thing. I'm going to perhaps just check continuity on the reset line. So let's see, we've got reset and reset is this one up here. We've got continuity, okay. And reset is that one here. Oh, hello. Okay. All right, so that's going. And I suppose I wonder if we can see that being held anywhere, or if we're going to need to start getting a Oh, I've got that the other way up, so that's why it's showing negative. So that's currently held high. And does that reflect this being held high? Yeah, okay, so that's being held high as well. Right, but who is holding it high? So given that this is a bidirectional bus, now the other thing about this bidirectional bus is, depending on its implementation, I'm tempted to suggest it may actually default to high, or maybe something like some transistors you pull down. I mean, that would be a... So actually, if we go for the one that's not connected at all, yeah, so that's being held high at both sides. So even though it's not connected to anything, so okay. But just to verify I'm happy with this, if I hold that pin low here, and I realise I'm okay, and is that low? Yep, but that won't affect any other pins. That's right, so the other pins are just fine. And okay, so is that being held high all the time? It's not being held low. Okay. Let's plug that back in to pin 4 there. And we know that this is trying to send chip detect bytes. So no chip detected. Oh no, we want to look at it here, I suppose. Error, well, ERO. Interesting, so it'll write an error regardless, and I presume the other end is supposed to detect that error, whatever that error is, dependent upon the stage it was expecting to run this at. Is that correct? So if we go to the other code over here, where we're looking at the source code for Windows, and okay, we read the device, open the port, DTR, enable DTR, no, okay, yes. Right, is that going to go and give us a nice reset on the Arduino, I presume? Exist, file open, okay, it's opening the file. Ah, terrible indentation. Ah, and it's all one function. Ah. Right, okay, so they're going to read it in a bunch of blocks and enable the transmission. So, wait a minute. I jumped past where it was going to do something here. Open COM port, and is that what we got in that? COM port open, file open, block total, enable transmission, request sent already, waiting for response from Arduino. Right, okay, so while this process program, upload failed. File close, compot closed, no chip detected. So what does it try to do? So it goes into this. So that's it. Okay, while not some end condition. Is end a global? Yeah, of course it is. Okay, so it's waiting to end. It's going to run this little process here. If there are bytes on the port, but hold on, has it actually sent? Send COM buffer. buffer is sBegin, right? Okay, so I presume sBegin has an equivalent thing here, hopefully with the same name. Yeah, okay. And this is another, so that looks like the right thing, okay. And therefore it's going to, well, let's find out what it does. Okay, we've got, so sBegin, serial available equals 2, so we've got 2 bytes. And we read 1 byte, we get the verified byte, continue equals 1. Okay, and there we go. So then we go into debug init, which is the thing we saw before, where we go and go into debug mode. And then we try and read this chip ID, which we saw before. And if we fail to, we write error. So we've now sent that. So case error. Okay, depending on where we are. So if we're downloading, it's one thing. Okay, so yes, otherwise we're in the state where we've not sent anything yet, so it's waiting for the chip ID. Got you. And if it gets the chip ID, it'll start downloading or start uploading, if you like. Right, okay, so we can see kind of what's going on. That means that this has, after sending those bits, it's waiting for data to be an output. Right, command get chip ID, and is that, that's just a def somewhere, and oh, can we get the first one of those right? Debug bytes. Right to bug on debug interface requires DD to be output when the function is called, and we've got the data. So okay, so it's actually bit banging that data. I take it if we've got anything in the high byte, write the high byte, else write the low. Okay, write high or low. Oh, I see. So it's shifting it out. Right, got you. Yes. So high clock, send this, low clock. Right. I think we are going to need that. I think we're going to need to connect it up. So I haven't got a better way for you guys to see what's going on here than here, because I don't think I've got anywhere over here where I can stand this. But let's find some power for it. And we can start debugging. So what can I be suspecting at this time? Well, okay, again, it's that for me the this level shifter is my first suspect. I suppose it appeared to be doing part of a job, and it appeared to be able to do serial both ways, but if it's actually holding things high, and they shouldn't be, that's no good at all. Oh, I appear to have boxed myself in. Let's just run that down there. Okay, and we'll just pull this over. Right, so let's connect it to, oh, I suppose actually no, it's not that one. We want to connect this one, and because I don't want that to be not connected, let's go give myself a nice easy clear tab to stick that up on. Why don't I have a, it'd be nice if I had a banana plug end. I mean, can I no, there's no easy way to do that. I don't know if I can safely assume that's grounded, but I suppose I can safely assume the bottom of this cap is grounded. or is it ground? Now we're getting into, right, so that's my reset, so we should at least be able to see reset. Now the other annoying thing is, although I have a 4-channel scope in terribly poor show, I have only one probe at the moment. I believe I only have one probe anyway. Oh, is that going to go in there? How can I connect that? I know. We just get a little tiny bit of wire, because I can't quite get that round there. So we should see the reset do something when I start that up. Okay, let's, don't know how it's going to behave sideways. Oh, right, power might help. Better than zero scope, zero probes. I have no logic analyzer either. Actually, so it's almost criminal that I have. Well, none of it criminal, but I got sent a bit of a freebie at Christmas. I got sent a freebie by Dangerous Prototypes, and what they sent me was an empty Bus Pirate PCB. Which actually right now a non-empty Bus Pirate would be quite handy. Unfortunately, yes, it's an empty PCB, and I'd probably have to go and find the bill of materials. By that time I might as well have just bought the Bus Pirate, because it's probably going to take a while to put one together and get all the code on it and so on. Okay, right, let's see. Now, it's going to be odd because I've never tried to power this up sideways, so let's see if it behaves itself sideways. I mean, there's no good reason it wouldn't. 5 volts AC coupled. We don't want it AC coupled, probably want it DC. And 5 volts for one gradation. Let's go for 2 volts. So that's roughly 3 volts there. You guys can't see that at all. Oh. Salia clones, cheap as dirt and quite handy in a pinch. Oh, I've not come across that. Is that what? Sorry, is that a Salia? Is that a Bus Pirate clone? Okay. Slight diversion here. Salia Bus Pirate clone. Is it? Well, that's the original date. Oh, I see. Right, there's Salia USB logic analyzer. Oh. Right. So there's stuff there for 219. Is that just the cable, or is that the whole device? Goodness. Right, well, that might be a diversion for after the video, but thanks for the tip there, Paul. I'll have a look. I could do with some, a logic analyzer for this. Right, so I'm expecting at least to see, well, okay, I should see at least the reset low and reset high. So the clones do work with their software. Oh, what, with the Bus Pirate software? Oh, that's awesome. Okay, I like that. Right, let's go get the command line up, and I'll tell you what. So you've got a hope of seeing me with the scope. I'll just turn this camera ever so slightly. You can tell this is attached to the Arduino by this cable. There we are. It's all slightly precarious there. And let's see. So if I issue that command here, and what time base am I on? 0.1 milliseconds. We can go out a little bit, I suppose. That's getting a bit flickery, but I'm going to keep my eye on there. Oh, okay. Let's try and do that. If I do that again, it's quite hard to see it because this one is not a digital. Oh, with Salia software. Oh, I see. Sorry, yes. So the Salia clone works with the Salia software. Yes, okay. And it can live decode USB. Well, okay, it's not USB, but still awesome. I mean, as in, yeah, that would be a cool thing to do. So you guys are just seeing a blob on the oscilloscope back there. Don't know how to get a better. So I can definitely see that drops. So now if I go to the next pin along, which I believe should be what, the P21, and was that the data or data clock? Hold on. Data clock is P22. It's this one up here. So we'll plug in over there somewhere. And that's currently at 0. Okay. Alright, now let's make sure those never touch, because I wouldn't want that to short there. That would be bad. Make sure nothing's getting toasty there. Okay, and let's go back and I saw it. Hold on. Trigger. I do a single. Can't. Oh. Again, not being a storage oscilloscope, can I get this to actually give me any kind of hold? So it's doing a trigger, it's hitting the not triggered light, which is fair enough. Time-based mode, auto trigger. Okay, let's try it that way. There was something there, definitely. Can I get it to single? I mean, it's definitely there. I don't know if there's a way to get this old thing to hold. XDFL, what's that? Oh, X deflection, of course it is. Yeah, it makes sense. And we'll go back up to this trigger there then, because it will trigger every time we do it. But actually we want to trigger on the downward edge, right? So we should be seeing 1, 2 downward edges. Now if I had 2 channels, I'm hoping that would correspond with the other bit. So we're seeing the 2 downward edges, which suggests that that should be putting this into debug mode. Does it actually do anything to say send it's there. So it says it's in debug mode. Reading the chip ID, okay, which is the next thing this is supposedly going to be doing. So 0x68 is read chip ID. Get chip ID, debug instruction returns and chip revision 8 plus 8 bits. So presumably it hands the bus over and goes into some kind of input state. Let's go to where it does the chip ID. Okay, wait for the thing to be ready. How does it tell when it's ready? Pulls data DD low when ready. Okay, and I'm on DC, so okay, so that may get pulled low. We should be able to see some activity here, but we can't really tell from whom it's come. Let's can we do hold off? What does that do? Oh, that's holding off the triggering. No, we don't want to. What does that do? Okay. What does BWL do then? So frustratingly, there's lots of stuff about modern DSOs as opposed to this, which is probably about 20 years old. There must be a way to do this. Setups. Okay, this is where I can set up front page text. Let's not do auto set. Screen and sound. Oh, I turned off the screen, the sound, because it frustrated me very much while doing it. Maintenance probe. Probe correction. No, okay, I don't think we're too worried about that. Cursors. Oh well, that's lovely, but if you can't actually, if I can't work out how to get it to hold, how do I turn them off? Yeah, okay. That's the time-based mode. What's this? Edge, channel 1. Nope. Status. Okay, that's just showing all of the parts. I'm just currently finding out something about the data sheet for this for oscilloscope, and see if I can figure out how to make that do. Ah, yes, okay, so it's triggering multiple times there, but I don't know if I can get this to show, because I can see that it's being, something is being sent, but it's just a flicker. You can see it being triggered. And I can see, oh, I went too far back there, didn't I? Huh. Okay, right. Something is definitely happening here. I mean, we're not getting nothing at all. But the other thing that has me vaguely worried is that every pin here, I'm presuming, is well, I don't know if it's floating or again being held down by these. So that would perhaps be in the JDY-08 datasheet. Are there pins that are being held up, down, and otherwise, or are they all just floating? Debug board schematics. Do they mean this board schematics or what? They're showing a debug board connected to the device, which isn't quite that. Yeah. Interesting. There's a whole bunch of okay from the I/O pins. That's your voltage regulator, which we have in, although they've got 2 caps and I've been, oh, they've got 3. I've been rather mean in giving it just the 1 on the output voltage there. Okay, so that's going to be what your okay, USB to, right, okay, USB to serial. Oh, I love how they've kind of not really bothered moving these around. It'd be nice if they had like serial coming in this side and then sorry, USB coming inside and serial coming out the other, but hey, you know. Which is just going to across to these, so they aren't really showing these connected to anything. Oh no, here, right, so 3 pins there doing that. And they're not showing either of these connected to reset, which I suppose if you were to follow some of the ways that you do things on the Arduino, where the DTR, the RTS, one of those connected through to reset, would be such a bad idea. So this is showing these wiring diagrams, but they're not showing the internal wiring on the device. Now, is that because it's basically the same as the app note over in not the debug board, but over here? Is that what it's going to be? Because some of these breakouts are simply the app note with things coming off. Well, that, no, there's doesn't quite look like enough. I mean, we've got the 2. Okay, I can see 2 crystals. Got 1 resistor, 2 1 capacitor. Sorry, 2 3 capacitors, 1 resistor, 1 2 3 4. Bunch of inductors, more capacitors, more capacitors. So maybe it's quite hard to tell. Maybe that would be a job for the microscope to identify these 2 crystal clock speeds and see. Okay. So See, I suppose I'm slightly running out of ideas on what to do there, given that did it signal anything at all? So perhaps what I could do is, instead of this code which does things in a if you like deferred way, oh, I can't create it there, can I? So what if I was to create up here a folder, cc test, and let's create a cc test.imo. Okay, and what I'm going to do here is simply request that chip ID debug in plain text over serial, return, oh well, yeah, prints out what I got. Okay, we're going to try and go way simpler than what we had there. So we'll have a void setup and a void loop. We'll nick a few of those hash defs, and we'll nick a few of the other bits from that ccloader.ino. Oh no, that's my video notes. So let's start here with we'll use the same pins, clearly, and we don't need those. Not sure if we're going to need those. We'll get to them later. There's no includes, that's nice. Where was that OX68? Oh, here it is, command, debug commands. Okay, well, we're only going to do get chip ID here, so don't need those. We don't need those either. Okay, so let's go straight up to setup, programmer init. I'm going to do that maybe, yeah, okay, well, did we actually, before we got into programmer init, even set which pins are in which pin mode? Oh no, there it is, programmer init, sure. Pin mode, output, 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 digital write, low, 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 okay, reset high, sure. Let's do that. And we'll take that with it. Okay, so we can do that. We need to make sure we set up our serial. So we're gonna, yeah, we're gonna do it with a nice fast one. And serial dot write or dot write line. My Arduino reference, language reference, always handy to have one of those. Let's put that next to that, and where is it? I just scrolled right the way past it. Serial. Print line. Okay, serial dot print line. In fact, we'll do this here. Oh, we can do that right at the beginning. So programmer initialized, and we'll do this. So we'll be slightly chatty, but I'd rather err on the side of being chatty here than otherwise. Oh, where's my? Oh, that's where my live dashboard went. No problem. Right, okay, so let's say asking for, right, first before we ask for the chip ID, I think we did a reset on the device as well. Do I want to help us improve the CPU extension? not now. So in their loop, right, well, 0 available, blah blah blah, 0 read, debug init. Let's get into that. Now the only thing is, of course, I suppose there may be a timing thing here, which is that if I send stuff to print on the serial port, then it may be too slow for what we're bit banging in from those random pins. So there may be something in trying to work out if I can do some kind of interrupt, let it trigger on an interrupt, save what I've got, and then perhaps on the next loop go, oh, I've got something in that buffer, and I'll print based on what I got there. We'll get there. Let's just do the basics before we get there. So let's go and pick up this one then. And we've got low, low, high, low. So this will go and hopefully put us into this debug mode. We've no way to tell yet if it's going into debug mode. So program initialized, entering debug mode. Okay. Now we've got the debug mode. Then we do want to do this read chip ID. So make sure we're in output mode. Take 1 millisecond. Write the command. Go to input mode. Input mode and write high. We're pulling up. So we're going to input mode and hitting the pull up resistor. Okay. And we wait for data to be ready, which we'll have to find out what that does. Read, pin mode, that output. Okay, I am going to again nick this and nick its dependencies. So that's okay. We'll pick up bits of this. And that means we're also going to need this write debug byte. Let's do it. Just writing it to the debug interface. That makes perfect sense. Okay, so it's going to inline that, so it's a bit faster. Fine. Okay. So if it's high, we go high, otherwise we go low, we clock through, and then we go, okay, yeah, fair enough. So clock high, bit goes high or stays high, clock over. That's a pretty simple data and clock setup. Okay, we want to read debug byte. How do we do that? We start off with no data. Again, we're going through to 8, write it high, shift left by 1. If we've got a high read or 1, clock low. Okay, so we control the clock, the other device is setting the data line. Okay, that kind of makes sense. All right, and wait for device and the programming to be ready. Again, we'll drag that in here. So try to put it after the bits where we needed it, have we? No, good, okay. Pull it low when it is ready. Okay. Oh, so we pull it up, the device then pulls it down. Okay. Interesting. I'm just thinking again what interaction that's going to have with this this bidirectional device. Again, nothing is getting warm, so not too worried about, say, something pulling up while something else is pulling down and kind of creating a nice current thing through. That wouldn't be nice. Okay, so if we've got that, read out the 8 bits before count, return the 8. So 0, count below 16. So we read a whole byte. Why are we doing that? Why do we clock out 8 bits before checking if it's low again? Count equals 16. Okay, so count equals 16 is we've possibly timed out, so we're waiting. Okay, read debug byte. There's a bunch of clock ups and downs here, but we're controlling the clock line, so that's at our own pace, I presume. But this, we're not controlling the clock line until we get to it's been held high, and these clock out 8 bits, we discard them. So while it's still high, so it's not been pulled low, clock and read it. Okay, so we do a couple of clock signals until it's ready. Oh, okay, so maybe we're doing clock cycles. So does that mean it's step debugging through, and we've kind of given it instruction, and then our clock is clocking it through processing our instruction until it's ready to respond? Is that potentially what's going on here? Okay, and read chip ID. So we go to output, read a debug byte, we wait for it to be ready. Okay, so if we got there before we have 16 clock cycles, presumably, or sorry, 16 times 8 clock cycles, so 16 times 8 bytes worth of clock cycles. So if we have, if it's not, we have 0. If it is, we have no. Okay, oh, okay, so, right, if it is, we have 1, so if it's ready, we do that. Otherwise, it's not ready and we don't appear to do much. Okay, well, let's see. So, int, unsigned char ID, we'll use the same one, equals 0. ID equals read chip ID. Serial dot print line chip ID was, and is that a printf style thing? Nah, it's not. Okay, so we'll do print chip ID was, and then serial dot print line ID and the format number base. Oh, we can print it as ASCII encoded decimal, so we don't need that. I presume we don't need to do much in a way in terms of looping, doing a cleanup here. I mean, I'm going to be resetting anyway, so. Chip erase. Why are we doing a? That's okay. That's when we were doing something else. So we aren't going to be doing a chip erase yet. Read chip ID. Return no chip detected. Run the loop again. Oh, right. And that's just waiting for us to start again. Okay, which will come back round to waiting for something to be in our buffer. So until we get an SBegin, it will just clear everything. Okay, so let's try this thing. I mean, is that if it's only getting 0? You consider that a problem? Yes. Okay. Just had a random beep from somewhere over there. I don't know what that was. It can't be this because I've turned off the beeps on this thing. Okay, so let's try this code. Let's see if it does anything useful. Let's see what output we get. So if I open, go up, go to this, and oh, it's over here. We'll upload this. Well, it compiled, that's a good start. And okay, take our serial monitor. Where's that gone? Did I get one? Where's the serial monitor go? Oh, on the other screen. Yeah. Ignore. So let's be more specific about what we mean. We can turn off that and upload this again. Bring that back. Didn't get ready signal. Okay, so this thing here. Again, I suppose I should assume perhaps that their code works in other scenarios. Is this that we aren't hearing a peep back? Have I got this connected right on that DD? Well, I saw it pull it down one way, but did that on this one here, P21? Let's just make sure that we have continuity on that. So that's this on here. Are we? Let's just make sure I'm getting. Oh, probe fail. Have I got? What I was saying about the multimeter earlier being pretty trustworthy, and now it's letting me down. Right. I mean, is that just because of the crustiness on this? What's that about then? Okay, here this should be. No, I mean, are we just saying? Come on. It may be that I need a new battery in the. That's more like it. And in that case, that's this one up here. So we got clock and data coming all the way down. We already did so reset coming all the way through. So we know that those are connected through. That's something. Again, nothing hot here, but it does not appear to be coming back with anything. Let's just reset that and see it do it again. Yeah. So debug overview of the so we'd be expecting where's 2541? Whereas we got the 2541, that's showing the 2543. CC devices. I wonder if I can find what that chip ID should be here. chip ID. Just looking for the term OX something or other. Not quite. Oh, I see. There's the right. Oh, what was that? No. Oh. Okay, so there's not much describing that there. Does this show links to other further data sheets on it? I mean, I'm definitely learning a lot about what the device does and how its debug system worked, I suppose. But we're kind of, in terms of actual results, we are no further along than we were when I started, apart from what we do know, I suppose. Okay, that we've now got the data sheet there for how we program it, which, presuming that this is the same device as some of the others, that's nice. We also now have this little bit of test code, which, assuming this is correct, this waiting for the device under programming to be ready. Oh, and I learned that term. So there is learning being done here, but I don't. I'm not getting anything out of it. The other thing, actually, since it's powered up, is does the device, does it still show up if I do a search for Bluetooth devices? So Bluetooth is off. I'll turn Bluetooth on. Connected. Okay, so I mean, the device is alive according to this, and when I went to devices and printers, there were no services on the thing, were there? Because there's just no drivers, so why would it have anything? So it's alive. We got an ID here. I mean, it's not that the chip is dead, it's that we can't talk through it through any of the interfaces we're trying. Which is slightly better than completely dead. Right, does anyone have a when it doesn't work here? Now I'm also going by the chip labels I've put on the breadboard, the breakout that I made. Are those accurate? Well, in theory, they came straight out of this, so it would be assuming if this is accurate, that's accurate. And given that, yeah, okay, well there you go, PT2, PT2, PT1. Well, okay, they are as accurate as this data sheet is, so I don't believe we've got a problem there. And the reset again seems to be there. And there's no This certainly is going to make for some bedtime reading for the next week or so, I think, going thoroughly through this data sheet along with this one, but I think this is more electrical characteristics and power saving. It doesn't really tell me anything about programming the thing. Well, I mean, okay, there's these things, but it's maximum 12 megahertz. Nah. What are we waiting with there? We're talking milliseconds, so we're not. So without getting into the implementation here, that's 10 milliseconds in the debug init. If anyone on chat there has any ideas on what to go, where to go next with this, or would like to ask some more questions about what I've tried and what I've looked at, please do feel free to ask. So enable debug timing. So it doesn't matter where that is, it's these two falling pulses while the clock, while the reset line is low, that is making things, or should be making it go into debug mode. Debug clock has to be ahead of the debug data transitions. Okay, right, yeah. So the rising edge for the clock high has got to be before the transition. So is it the the falling edge where that transition is then, I suppose, shifted through to the rest of the system? Is that what we're saying? Debug data to, debug data from, so we clock and we get the data from there. Allowed high pulse on clock. 35 nanoseconds. Allowed. Clock data setup, debug data hold. No, okay, I'm not so much interested in those. Well, logic 1's minimum 2.4. Well, we're way over that, so that's not a problem. These 2122. I can't really see from there what those pins are there. Let's get a bit closer here. You have to start service local service. Okay, so Bruce, what do you mean? Some kind of local service for something? What kind of local service are you thinking of here? Be interesting to find out. Okay, again, I mean, Bluetooth needs to be restarted. Oh, on Windows. I suppose, I mean, what I'm trying really to do here is get this, so to get the debugging interface to talk to me, so I can flash it with code. So the Bluetooth service, okay, perhaps. I mean, there's no good reason I couldn't do that. Bluetooth support service. So it's discovered it, but there is no, I mean, the device has nothing going on it because I suppose I've put no software to load any particular profiles on it. I suppose I could restart it. I don't know really what it's going to do. Isn't really. I suppose it actually, there is a possibility that the computer is doing something, talking to whatever firmware is on the device and putting the device in a state. But I believe the debug interface, when it's reset, is supposed to override that. But okay, let's have a look. If I now bring up devices and printers and see, so I've done the device, I've done a restart in services to see what that will do. Now the other one is perhaps to make sure I have got nothing paired with it, but again, thinking about this debug interface, presuming that this is the same debug interface, since this is also a I suppose it is one of these CC2540 4X devices. If it's in this debug mode, would that not suggest that it's not going to be running the code that's on board, that it would actually be stalled and not allowed to run that? And let's see. Well, this is getting into when this has been and gone. Okay. Slash programming devices code example. There's a user's guide here. Oh. Ah, okay, that's interesting. So we've got memory maps, we've got physical data, we've got, so this is a little bit more interesting. Debug interface, let's go, can we go straight through to this? Debug mode, forcing 2 falling edge transitions on pin P22, debug clock while reset is ends held low. Oh yes, it's still, by the way, it's still here. So we are still actually connected to it with no services, but then there'll be no services because we've got no known real driver or device information, so that's fine. But I can at least perhaps tell this to not be connected to it. We can add it back later, so just in case that's doing something to it. And we can go back, hit this, hit reset on the Arduino to see. So yeah, we're still not getting the ready signal, which suggests that we're still, I mean, I suppose it's telling whether we've gone into debug interface and so we go init the programmer or program init. I mean, I've got it program init, but that's where we've just set all the pins low apart from reset and made sure they're all outputs. We go to debug init, where we're telling the chip to go into debug mode. So we hold both those pins low. We held reset low, go high low, high low. So we want 2 falling edge transitions, high low, that's a falling edge, that's falling edge, and we allow it to go back high again. P2.1 or 2.1 is the bidirectional pin and debug clock input pin. Cannot be used with a device system clock when running a debugger. Set to 0 or this or this. I don't know about what that is doing. SPI like 2-wire, data driven on the bidirectional positive edge of the debug clock. Always starts with the host transmitting a command through the serial phase. This command encodes the number of bytes containing further parameters to follow and whether a response is required. That, in this case, we aren't really writing the number of bytes, we are just writing, so make sure we're output, wait, and we're writing just this So hex 68, which is your get chip ID byte. Going straight back into input and holding it high. Okay, so the host is holding high, the other end is supposed to be pulling it down. Should we be doing that, given that we've got this logic level shifter? Okay, let's go over to here, and if I'm not wrong, writing that high means we are doing presume that means we're doing a pull-up. That's what I inferred. But digital right high offer configured an output or voltage reset. If the pin is configured as an input, will enable high or disable low the internal pull-up. So we've got this pin mode input digital right, that's internal pull-up. Input pull-up to enable. What's the difference between input and input pull-up? Is that input with a pull-up inferred? Input pull-up or output? High impedance, small bands, blah blah blah. Okay, yep. Internal pull-ups. Voltage is below ground or above the positive rail. Yes, okay, that's fine. So the first thing I'd be wondering is, but I mean, I'm presuming these two operations is this, but then there may be in the Arduino the library code that makes it do this, there might be some delays between doing that and that you don't get if you do input pull-up. So I'm going to be ever so slightly adventurous and try that. Is there anywhere else where I think I need to be in input mode? No, so it goes back into output. So let's try that. Okay, I'll send the code. A minute. I need to close that first. Okay, we'll go pull up our serial monitor again. And off we go. Okay, that really didn't make any difference at all. Now I'm realizing I'm shifting many bytes if I do this. There's this thing here, this wait ready, which we're doing here after doing our write. Write our debug byte, go into this here with the pull up, wait a millisecond and then wait for it to have. I'm still kind of wanting to find out about that. Start a command sequence, command byte, data byte. So based on the command encodes a number of bytes. Okay, so fine, that command probably suggests there are no further bytes based on the command. Controls the direction of the debug data pad. Okay, a debug module, not the device, but that's because we've said it's allowed to be in an input state and output from the device. Double command sequence. No, it's a debug data signal. Is yeah, okay. Direction change. Sample by the output device asynchronously. So what is this? Why are we trying to pull that high? must be a small idle period between the command and the response for the pad to deliver. After the minimum waiting time, T-JDY change. Is that a table up here somewhere? Not quite. Transmission of 1 byte. Start byte, end of byte. Okay, most significant byte first. Fair enough. I believe that is what we're doing. Yep, okay, because we're shifting left, so right, that's fine. That's no extra wait for response. Wait for response. By putting the data high, that it's not ready to return data. Okay, wait a minute. If the debug's interface indicates by putting that it's not ready to return data, the external device must issue exactly 8 clock pulses before it samples the ready level again. This must be repeated until the level is low. The wait cycle is equivalent to reading a byte from the debug interface, but ignoring the result. Note that the pad starts to change direction on the falling edge of the debug clock. Thus, the pad drives duration should be minimized in the program's implementation. Eight clock bytes, the equivalent of 8 clock pulses, the equivalent of 1 byte. Wait a minute. So we're reading 1 data byte, but hence why we're putting it up high. Input pull up. Yeah, that does. So you don't actually have to write your high. There you go. That's nice. So it does do what we thought. That's good. So yes, that's fine. But it's this waiting this to be ready. Clock out 8 bytes, and then check if we're low again. Clock out 8 bytes. Result equals ready. Level is sampled. Why 16? Oh, because actually it's okay. So we do this 8, then we're expecting it to be low. We read 8. So that's the pad starts to change direction on the falling edge of the debug clock. On the falling edge of the debug clock. So the falling edge is low, which means this would be changed if it's going to do it. I wonder, I mean, it's going to be slight overkill, but what if I do serial.println data? And I suppose data is, can we do data hex? Does it know how to do that? Serial monitor. Alright, we are just getting FF, which presumes it's being held high the whole time. Right, okay. see a whisker or something there. It might be just bit of hair. Oops. As you might be able to hear, I don't know if you're picking it up the other end, but there's a storm raging outside here. See, the fact that this appears to be pulling high already without the assistance of that. If we floated that, this device would be pulling high unless we have something that's pulling it low. But if that's pulling high and this is pulling high, would that be able to pull low? So if we've got a pull up and a pull up here, I can experiment. What if I just go to input and don't set up that pull up? I mean, that's a possibility, right? Okay, didn't make the blindest bit of difference. And obviously this next read after there, out of this clock low, is always high, so it's never being pulled down by the device. Now, thinking how some kind of outer logic analyzer, which I don't have currently, I would be able to tell if the device is doing anything on that port at all. Now, I believe that Arduino is running at 16 megahertz, and it did say here, so it was a maximum. Where did I see that maximum? I did see a maximum speed, but that's a maximum speed for that clock, which is going to be, oops, excuse me, getting tired of there. So the maximum speed of that, where did I see that? Was that in this data sheet or the other? That must have been in the other. Because I saw a table. Here, debug clock for 12 megahertz. But I mean, given that we're doing it in here and doing it in fairly high level Arduino operations, we're talking, what, at best 4 megahertz, if that. I mean, that's probably vastly overstating what this is going to be doing by bit banging out here. So I mean, here I suppose there's no delays apart from whatever's in there, so it's going to be going out as fast as it can do so. And again, unless there's a delay baked into digital write, I don't know. Now, does the documentation again for this digital write? Can I get to the source? Again, just quickly check, nothing's getting hot, so there's nothing going and being shorted through, that's good. So we haven't destroyed anything, but we haven't gotten anything here to talk to us apart from the fact that we can connect to it with Bluetooth, which means there is power getting to that device. There's no onboard LEDs to show that it's doing anything. Maybe if I were to do another revision of that carrier board I've made for that module, maybe I'd put an LED on there just to indicate that there's power going to the thing, and maybe even some LEDs showing, you know, the data, as in showing activity there. See, I'm just thinking, if there is a Bluetooth device we can see there and it says it's JDY-08, there's got to be firmware on there, which comes back to we should be able to read serial. Okay, I'm going to again see if I can go back from trying to program it and just see if we can get the AT part to do anything, but kind of at a loss as to what to do next with this device, unfortunately, apart from read the data sheets, which I'm not going to sit and do here on my live videos. That would be somewhat dull for everybody, so it made me read it and come back when I know a bit more. Let's disconnect this, take out the Arduino connections, bring in the serial board, Android BLE scanners. Well, I definitely know that in terms of BLE we can see it. We know it's alive, at least as in things are clocking there as a device. Actually, well, let's just make sure we're not clocking something that's, you know, not actually in the system. So if I go, having removed it, so if I go to Bluetooth settings, and there we go, so it's not showing up as there. So if I then connect this device up, we're gonna just go, and what have we got? We've got ground. I'm gonna take these away, they'll go across to TX and RX. Oh, wiring from up here. Parallax on the breadboard really gets you. Okay, we've got that one I don't care about. There's your 5 volts there on the grey pin. And then we've got TX and RX on blue and purple. Oops. Oh, that one didn't want to go in. Okay. Yeah, that's not brilliant. They don't have profiles, so the driver is always user space. That makes sense, actually. Right, now, did I need to hold reset up or down? What was the thing on that? I suppose if I don't want to enter debug mode, do I just want to set it and hold it high? Let's take reset, this one here, and guess there's my 3 volts high there. So I'm going to hold reset high. And keeping my eye on anything. Okay. BLE devices don't show up like a COM port. No, I suppose that's true. Well, I suppose, okay, so there's no way to get, say, a serial port profile or get it to emulate some known device. It's all user space. Can't even pair with them. Windows let you do that with one of those scanner apps. You can do something on your phone and see it on the serial. Well, that was what I was hoping to do, was maybe type something on my phone, have it come out. Oh, I see, on the serial the other end. Right, that makes sense. Oh! Am I still with you? I think sorry, I was plugging something in. I think I managed to knock a sleep button on the laptop. That wasn't actually what I plugged in. It's the laptop. Okay. Nothing's toasty, nothing's hot. That's a good starting sign. Right. There isn't. This is COM6, I suppose I'm on now. So let's just go and grab port COM6, do a serial monitor, and take away ground. Oh, so I've just unplugged what I thought to be ground here, and that's still lit up rather nicely. Why is that lit up? Oh, probably because I've still got the oscilloscope connected, which I've not taken away, and the oscilloscope might be mains earth reference. Yeah, okay, let's get rid of that for a second. In fact, we can turn off the oscilloscope because we aren't really doing anything with it at this point. And this is where I'm hoping I could do AT, T plus, T plus, okay, that's the oops, nothing, not even an echo. Android ER Blogspot Connect please. Okay, let's have a look at this. HM Bluetooth to Android. Let's try this, because at the moment, having gotten nowhere, anything's worth that. Oh, am I on 9600? No, I'm on 115200. Let's try 9600. Why not? We'll reset the device in case it does anything. And AT. I'm at least expecting, hoping to get errors if I give it something it doesn't understand. This is possible. Nothing from it. How strange. Oh, I see why it did that. It's no longer going to imply that. No? What? That was just bizarre. Why is it going to search for a URL? Connect this to Bluetooth supplies. Bluetooth LE cat sample project. So HMT, HM10 Bluetooth 4.0 serial wireless module, which is, I suppose, what this could be. Line endings, yes, I went through the suite of line endings, so I'm thinking we've got those. Bluetooth LE generic attribute profile to transmit arbitrary data between devices. So we've got a video which I can perhaps watch at the end of that. Oh, spaces because you can't see. Oh, of course, yes, sorry, you can't send URLs in chats. Okay, maybe that's that makes sense. With an FTDI adapter, which is exactly what I've done here. I've connected it up to an FTDI adapter, so I will put that Oh, so he is actually not an app can download, so I probably need to get myself a Android SDK up and running. There are several, just not okay. There's other ones going. That's cool. So the cheap way would be to check my phone first and see if my phone sees a device there at all. So does it see anything? Ah, now it's interesting. So my phone doesn't see the device. Just called BLE scanner. Oh, cool. And if I go to this unknown ready to pair, there might be right. Let me just see if holding that pin low instead gets a different response. Hold on, because we didn't try that. So now I'm holding that reset pin low. AT. I'll try 115200. Power cycle it. I'll try setting AT in many ways. So, oh, the system Bluetooth, it's not BLE but regular Bluetooth, okay. And now if I let's go here again. So it's interesting that it's now not showing up as anything at all. Ready to pair, ready to pair. Let's take out that there. How did I get it to detect this thing earlier in the other mode I had it in? Was it genuinely this device? Oops, let's not let one of those stray onto one of those pins, because that could be disaster. I'll tell you what I'll do is maybe I'll just connect them over here out of the way. No, it's not good when the goes away. And yeah. So the system Bluetooth will not find it. So I have to do a BLE scanner. Okay, let me see if I can find. I'm just going to check on my phone. So have we got a BLE scanner? Is there a BLE scanner? Oh, okay. I don't think that's that clear at all. Okay, well, we got this straight off the top, Blue Pixel technology. Free with in-app purchases. Well, look, I mean, worst thing is I can. Yeah, needs access to photos, media files. Yeah. Okay, so let's try that out. And we'll open that. Okay, oh. BLE, iBeacon, Eddystone. What is Eddystone? Well, that's another whole distraction. No nearby Bluetooth devices. Oh, hold on. 600308 C935 DC. There is something. There's a whole bunch of stuff. Well, that's interesting. There's just lots of stuff. I mean, raw data. Can I find out what that raw data is? If I'm listening on the... I might want to go and check if any of those devices are existing devices I know about. Perhaps I can go and find. So what have we got? Can we get so devices I have paired. If I go to device manager or devices and printers, even right click and find out their IDs. How can I make sure I'm not looking at the same thing? I don't know if this is showing. So I don't know if this is actually showing just the BLE devices or everything. Oh, pull the power, see if they go away. That's true. What, and then scan again. Yeah, that's a good idea. Pull the power. Scan again. Okay, that iBeacon's still there. So I've got 4 devices still there with power pulled. And nothing's getting warm. Nope, good. See, in that section, actually I could have put this down here, couldn't I? That would be a more sensible place for you guys to see what's going on. But we've only got 4 devices. Oh. Okay. Now if I get rid of this, just refresh. So there's plenty going on, plenty of other Bluetooth devices here. I can at least see what it isn't. So okay, interestingly, my so it appears that my activity watch thing is a BLE device. So that may be showing up. Maybe I should take that out of the room while I work. I don't know if that's going to be far enough either way. Anyway, can I get anything about the device description? Bluetooth device address. It's not one of them. Okay, that's odd. Is that what this is showing? Are these addresses? And why are they grayed out? Is that because they're already connected to something? Or is that because it's seen them before and they've gone away? If we go back to this here, where they initially show the thing here, so this is using an Arduino at 3.3 volts, and then show a picture of an Arduino Uno which is 5 volts with no converter. Which is a little bit cheeky because they've got it all running 5 volts. You should connect at 5 volts, see a below pick, it just works with some risks. Yeah, not sure I want to take such risks. I mean, I suppose I could see I've got a Nano that's being used on a robot, and I should check if that's a 3 volt device, because maybe if the Nano is 3 volts, then I could do away with the level shifter and stop questioning if that's where the problem is. That's doing something in between. So that might be another method of attack here. Connect power. PWRC to where? Configuration using AW. Right. It's saying, yeah, it's connect 3, but it doesn't say where that's being connected. Wake up pin, internal pull up, active low, connect to grounding to enter. Right, okay, let's go to that pin then. Active low. So this might get us into AT mode. I have got this also connected through to ground up here because that's wired down to there. Hold on, you can't see that. Okay, so that should put it in AT command mode if it's going to do it. Let's see. Nothing output there. Nothing output here. Oh, did we see some change here? Okay, well, let's start trying AT commands. Let's start from new line. Carriage return. It's going to get AT, I suppose, or some other. I'll send it twice just in case the buffer's got something in it. Both. Nope. Switch on 115-200. It's getting both there. So this is where I'm expecting AT command mode to be doing something. Now again, okay, I can try and reverse TX and RX because there's a possibility that they are not the right way round. I'm always prepared to reverse them as another stab at getting it to do something. Okay. Oh, start again. 9600 and new line and power cycle it. We don't have anything. Nope. One 5200. Was there just a straight 80 plus R? Broadcast name, read version 80 plus fur. Well, that should be the one I should be trying, right? No, we're not getting anything back again, so that's not necessarily it yet. Again, we've got this reset pin floating. They don't show reset hardware reset pin. It's interesting. The level is TTL level. Really? Is that really the case? So what are those actual pins on the device? Sorry, those pins are B02 and B03. Oh, okay. Is there anything to say that those will be 5 volt tolerant? No, that's the debugger. I'm going to treat that with some suspicion there, because I could take out the serial shift, the level shifter there on the serial things, but I don't want to. Yeah. On-chip voltage regulator. That's interesting. I mean, P02 and 03 are just. They're connected just to this I/O controller like any other pin as far as this is concerned. There's nothing special going on here. P02 and 03. Okay, I presume these USARTs are connected up, but supply voltage on the digital pin 3.9 volts, I suppose. TXRX turnaround. RF receiving, RF transmitting. We're not even getting that far yet. I mean, you know. Although it's nice to see if it's showing up on these to show if it's alive at all. Then, yeah, otherwise we're not getting anything there. Okay, I think I'm going to probably go away for tonight, because I've been on now for 2 hours and nearly 20 minutes. I'm sorry that it hasn't been more exciting, really. There's been a lot of debugging. We did get the oscilloscope out. I'm going to have to figure out a place to put it where it's easier to see for you guys. And to be honest, because I'm normally looking at the monitors here, then the only way I can see it is to turn my back to you, because that isn't a very clear picture on this. I think I've got a lot of reading to do, reading about programming this device and other things on this device. I suspect there'll be other projects as well, but I do definitely want to get this to talk to me, because it's just frustrating, you know. This I know I've been here before, only last week with a different device getting it to talk to me, but this is 2 sessions, and yeah, still not a peep out of it. But I've verified at least that those TXRX pins and the data clock pins are going all the way through to that carrier board. So it's not this here, and I don't believe it's these. I still suspect this, so my next thing might be to rewire this to maybe try a native 3-volt Arduino and program firmware on with that way. But I'm going to go and read these data sheets and maybe get to know this thing a bit better. And perhaps I'll do something a bit more exciting, not relating to this, in my next video, because I mean there's plenty behind me to play with. Thank you for watching, and I'll see you guys next time. Good night. Bye.